This video, like the last one, continues to build off of the activity that we did on Monday. So in the activity on Monday, we looked at the angles formed by two lines crossed by a transversal when the two lines are parallel. So once again, some vocabulary. Transversal is a line intersecting two other lines at two different points. And there's different kinds of angles that are formed, and in the activity on Monday, I kind of gave you a description for them using a river and a bridge as an analogy. But here are the angles one more time. Notice that corresponding angles are on the same side of the transversal T and on the same sides of the intersected lines. Notice, for example, that angle 1 is above line P and that angle 5 is above line Q. That's what they mean by on the same sides of the intersected lines. Same side interior angles, the name kind of tells you everything. They're on the same side of the transversal, so they're on the same side of T, and they're inside the intersected line, so that's why angles 3 and 6 are an example of same side interior angles. Alternate interior angles are on opposite sides of the transversal, and the text says that they are non-adjacent angles, which means you're not going to be talking about angles 3 and 4. Angles 3 and 4, remember from the last video, they are a linear pair. Okay, so angles 3 and 5 are alternate interior angles. And then angles 1 and 7, alternate exterior angles, they are on opposite sides of the transversal, outside of the two intersected lines. So when those intersected lines are parallel, that's where the real magic comes in. And on this screen, we're just kind of refreshing our memory on some vocabulary. Parallel lines are in the same plane and they never intersect. Notice in the diagram that L and M have these little arrowheads kind of going through the middle of the line. Those are to indicate that the lines are parallel. Notice the notation for when we're saying that two lines are parallel. And when those parallel lines are cut by a transversal, our angle pairs are either congruent or supplementary. And the first property that we have for those angles is on this screen. It is the same side interior angles postulate. Remember that a postulate is something that we just accept as true without it being proven. It's kind of one of our building blocks of geometry. So this postulate says if two parallel lines are cut by a transversal, then the same side interior angles are supplementary. So visually, if I have two parallel lines like A and B, if A is parallel to B, then angles 3 and 5 would be supplementary. So that means that the measure of angle 3 plus the measure of angle 5 would equal 180. In this example, we're being asked to follow the steps to illustrate the postulate and use it to find angle measures. So we have these parallel lines in the transversal and the angles numbered from 1 to 8. Part B, identify the pairs of same side interior angles. That's angle 4 and angle 5, and angle 3 and angle 6. So what does the postulate tell us about these same side interior angle pairs? Once again, it means that the measure of angle 4 plus the measure of angle 5 equals 180. Similarly, that the measure of angle 3 plus the measure of angle 6 will equal 180. So in part D, if the measure of angle 4 is 70, then what would be the measure of angle 5? Well, I could take this equation and substitute in the 70 for angle 4 So that means that the measure of angle 5 would equal 180 minus 70, which is 110. Another property, once I know that the same side interior angles are supplementary, and I'm kind of taking that as fact, I'm calling it a postulate, then I can use that to prove different properties about the other angles. So now we have the alternate interior angles theorem, which says that if two parallel lines are cut by a transversal, then the pairs of alternate interior angles have the same measure. Now, before anybody starts panicking about, oh my gosh, I'm not going to remember whether it's a postulate or theorem, let me tell you this. Every single book that I have ever taught in, the same side interior angles was actually a theorem, and another pair of angles was the postulate. And the reason why I bring this up is so that you realize it's not a big deal. Okay? If you write down same side interior angles theorem instead of same side interior angles postulate, nobody's going to mark that wrong. When we get later on in this chapter, what you will need to remember is whether you're using the original theorem or its converse. And we'll talk later about what I mean by that. But the point that I wanted to emphasize to you is don't stress out here about the difference between postulates and theorems in these properties. Okay? So on this screen, we are proving the alternate interior angles theorem. We are given that line P is parallel to Q. So that's my reason for statement 1, is that it's given. And notice I have this kind of reason bank up here, so I'm going to cross that out. I know that angles 3 and 6 are supplementary. That's the same side interior angles postulate. And please understand, if I abbreviate something, you can abbreviate it as well. There's plenty of writing in this class. Certainly, if you have something that can be abbreviated, go ahead and do so. Once I know that those angles are supplementary, then I'm saying that they add up to 180. That's the definition of supplementary angles. In the next, I should be crossing these out. You may use a reason more than once. Okay, so no reason for us to cross out our reasons. So angles 5 and 6 are a linear pair. And the instructions say complete the proof by using the following reasons. The book considers this to be given from the diagram. Once I know that those are a linear pair, because I look at them and I see that they are a linear pair, then I can conclude that they're supplementary because of the linear pair theorem. Once again, since I know that they're supplementary, I know that they add up to 180 because of the definition of supplementary angles. Now, something really interesting is happening, and I want to make sure that you notice what is happening. Look at these two equations that both have this 180 in them. Notice that in those two equations, the right side of the equation is 180. So the point that I want to stress to you is if you have two equations and either the left sides are equal or the right sides are equal, that means that the other side, whichever it may be, will also be equal. Okay, so what I'm doing is I'm taking these two equations and smushing them down into one in order to get this equation. That is substitution. And finally, from that equation in statement 7 to the statement in statement 3, notice that the angle 6's went away. Well, what's going to make them go away? Subtracting them from both sides. So that's the subtraction property. In our activity recently, we also noticed that parallel lines cut by a transversal form corresponding angles. And we noticed in the activity that when the lines were parallel, those corresponding angles were congruent. And so we're going to prove that here. This proof is in a paragraph form rather than a two-column form. So we're just kind of filling in the blanks. We are given that the lines are parallel. We're trying to prove that angle 4 is equal to angle 8. So by the given statement, I know that P is parallel to Q. Looking at the diagram, we can see that angles 4 and 6 form a pair of alternate interior angles. And so using the alternate interior angles theorem, we know that the measure of angle 4 will equal the measure of angle 6. And since angles 6 and 8, notice, are vertical angles, we can use the vertical angles theorem to say that measure of angle 6 equals measure of angle 8. And it says using the blank in measure of angle 4 equal to measure of angle 6, substitute something for angle 6. So if they're using the word substitute, then we should get that it's the substitution property. And we're substituting the measure of angle 8 for angle 6. And the result is that the measure of angle 4 equals the measure of angle 8. And you just might want to make sure that you're using an angle symbol properly. Accessing an angle symbol on my screen is kind of time-consuming and annoying. So I was just using the less than symbol. Make sure that your angles look like an angle symbol rather than a less than symbol. In this last example, we're using these properties to find angle measures. So in example 3, part A, that's been worked out completely for you, we're told in the diagram that the measure of angle PRQ, that's this angle, is x plus 40, and we're told that angle VTU is 2x minus 22. And it's going through this explanation of corresponding angles and vertical angles, and then concluding that the measure of angle PRQ will equal to angle VTU. Remember that in the activity, one of the pairs of angles that we discussed were alternate exterior angles, and they, just like alternate interior angles, are congruent. So if you just jumped to that rather than noticing the corresponding angles and vertical angles, then that's fine, because at any rate, you're going to end up with the equation x plus 40 equal to 2x minus 22. And then when you solve for x, you get that x is 62. Notice that the question was not asking you for the value of x. The problem was asking for the measure of angle VTU. So you have to plug that 62 back in for x here in order to find that the measure of angle VTU was 102. In part B of this example, we are given that PRS is 9x. We are given that WUV is 22x plus 25. And we know that angle PRS is equal to angle RUW because they're corresponding angles. So that's the corresponding angles theorem. We know that RUW and WUV are supplementary angles. So that means that when I add them together, it equals 180. Now the book kind of skips a step here that I want to make sure that you understand. It says solving for x, this equation. Understand what they did. RUW is equal to 9x, so they took the 9x, and WUV is this 22x plus 25. That equals 180. And so this 31x that you see, that comes from combining these like terms. From here, this is just an equation you know how to solve. 31x plus 25 equals 180. When I subtract 25 from both sides, I have 31x equals 155, and dividing both sides by 31, x will equal 5. And when I substitute the value of x in order to find the measure of angle WUV, the measure of angle WUV equals 22 times 5 plus 25. So 22 times 5 is 110, plus 25 is 135. In this example, we have these vertical lines that are parallel, these horizontal lines that are parallel, and then I have this transversal. This 126 is a same side interior angle to this 12x plus 2y. So I know 12x plus 2y plus 126 will equal 180. And I know that this 3x plus 2y angle here is alternate interior to this 36. So that means they're equal. So 3x plus 2y equals 36. Now I'm going to take this first equation that I wrote and clean it up just a little bit by combining my like terms. And what I mean by that is I'm going to subtract the 126 from both sides so that it looks a little bit more like this equation. X and Y stuff on one side and loose number on the other. So when I do that, I have 12x plus 2y equal to 54. And again, all I did was subtract the 126 from both sides. I haven't done anything to the second equation, so I'm just going to copy it down. And now what we have is a system of equations. And you have seen this before. You saw this in Algebra 1, when you have two equations and two variables, and you can't solve either equation alone. So what I would like you to remember from algebra is that there's two different methods to solving a system of equations. You can use substitution, which requires that a variable be by itself, which I don't have here. Or I can use elimination, which involves either adding the two equations to each other or subtracting one equation from another such that one variable will cancel out. And that happens when the variable has the same coefficient. And I do have that here. Notice that the 2y is in both equations, which means if I subtract this equation from this one, my y's will cancel out, and then I'll have one equation in one variable, and that should be very easy to solve. So when I subtract this equation from this equation, I get 9x equals 18. And oh my goodness, that's a much easier equation to solve. So I know x equals 2. Once I know that x equals 2, I can plug it back into either of these two equations in order to solve for y. Now, myself personally, I like this equation. The numbers are smaller, so I'm going to plug it in there. So I know that 3 times 2 plus 2y will equal 36. So that means 6 plus 2y equals 36. 2y equals 30, and y equals 15. And way up here, they were asking us to find the values of x and y and name the postulates or theorems that we use to find the values. Okay, so we knew that 12x plus 2y plus 126 equaled 180 because of same side interior angles. We knew that 3x plus 2y equaled 36. Because of alternate interior angles. And let me go back up here and say this was the postulate. This is a theorem. Therefore, x equaled 2 and y equals 15.